Hello everyone. So our today's topic of discussion is digit problems. So this is the another type of problem that you can expect in the chapter permutation and combination. Okay. Now we have already done a couple of videos in permutation and combination. The first one was where we understood the basics of P and C, like what is P, what is C, how do you distinguish the two. Okay. Then we also understood the concept of counting method. And after that we did some questions on word problems. So in this video, we'll try to understand how digit problems are solved. What are the different types of digit problems that you can expect in an exam? Before moving to the problems, we'll quickly go through the theory part of the digit problems. So let's start. So let's start by taking up a question. And there's one thing that you need to remember is that when you talk about digits in maths, there are basically only 10 digits. So we have digits from 0 to 9. So we basically have only 10 digits. Okay, and we'll try to evaluate, or we'll try to calculate for individual places separately. Like for example, we'll be solving the tens position separately, units position separately, depending upon the condition that we have. Okay, so that for every position we have only like 10 possible outcomes, so we'll try to figure out what can be our answer. So let's say a question is given to you that you have a set of numbers and you have 0, 2, 4, 7 and 9. So you're given a set of 5 numbers and the question is find the total number of 3-digit numbers that can be formed using the above given 5 digits. This is we are taking a very easy question just so that we can understand the concept, then we'll upgrade our level. So find the total number of 3-digit numbers that can be formed using the given 5 digits above. Now what are the things we have to take into consideration? Now, there are basically 3-4 steps which you need to follow. So if you want a 3-digit number, the first thing that you will do is you will draw 3 dashes, 1, 2 and 3. That's the first thing that you have to do. Probably the question can be you need to form 4-digit number or 5-digit number or 2-digit number or 7-digit number. So you will draw as many dashes as the number of digits in a number you want to have. So the first step is you will draw the number of dashes. Second is you will ensure that the 0 does not come at the first place unless and until it's mentioned otherwise. Because if 0 comes at the first place, now this will not be a 3-digit number. For example, if I talk about the number 039, do we consider this as a 3-digit number? No, we don't do that. We say it's 39, which is a 2-digit number. Or for example, if I say that 0784, do we say that it's a 4-digit number? No, we don't say that. This is 784, which is a 3-digit number. So step number 2 is you will ensure that the 0 does not come at the first place. Step number 3 is if there is any condition given to us, like in this case we haven't taken a condition as of now. Okay, so probably when we'll solve a couple of more questions, we'll have some conditions. So try to satisfy that condition first. And the fourth one is always start after the first 3 steps, always start from the leftmost blank. Okay, so there's a reason why we do it this way. I'll explain you what. I'll take up an example and try to make you understand why do we do this way. Okay, so we have a set of numbers 0, 2, 4, 7, 9. We need to find the total number of 3-digit numbers that can be formed using these 5 digits. There is no condition. It's a very straightforward, simple question. So what we'll do is we'll draw 3 dashes. Now 0 cannot come at the first place. So at the first place, how many digits can come? It can be either of the 4 digits. There can be 2, there can be 4, there can be 7, there can be 9. So 4 digits. What about the second place? Now see, in this question, it's not given that whether the repetition is allowed or no. But if I use my logic, and if I talk about three-digit number, can I say that 222 or 447 or 747909, all these numbers are valid three-digit numbers? Can I say that all these numbers are valid three-digit numbers? Yes, I can say that, right? So unless and until it's mentioned that the digits are different or repetition is not allowed, you can take repetition into consideration, because that will still give you a valid output answer. It will still give you a valid three-digit number. So you don't have to worry about whether uh, should I be allowed to repeat the digits or am I not allowed to repeat the digits. So you don't have to worry about that, because even when you repeat the digits, you'll get a valid three-digit number. Okay. So at the first position, you can't have 0, which makes up for 4 digits. For the second place, 0 can come, and any of the 4 digits, 2, 4, 7, and 9 can also come. That's like 5 digits. And for the last place, again, you can have 5 digits. You need a number at first place and second place and third place. You're going to multiply the possibilities. So 4 into 5, 20. 20 into 5 is 100. So you can have a total of 100 three-digit numbers formed using the digit 0, 2, 4, 7, and 9. Okay. Alright, now let's take up another case. Let's say we have the same question. So find the total number of three-digit numbers that can be formed using these digits. I'll add up a condition such that repetition of digits is not allowed. Such that repetition of digits is not allowed. Now in this case, it is specifically mentioned that the repetition is not allowed. So we are considering that case. Okay. So I'm going to make 3 dashes. Again, I'm going to follow the chronological order. I'm going to make 3 dashes. 0 will not come at the first place. There is no condition. See, still there is no condition. It's simply given that the repetition is not allowed. We don't consider repetition allowed or not allowed as a condition. Okay. I'm going to give you an example. What is meant by the term condition? So you can't repeat digits. 0 can't come at the first place. That makes up for 4 digits at the first place. Now, one of the digits that you will be using at hundreds place, one of the digits that you will be using at the first dash or the leftmost dash cannot be used again. For example, let's suppose you use the number 9 here. That means I can't use 9 here, I can't use 9 here also. So one of the numbers out of 2, 4, 7, and 9 which will be used in the leftmost blank cannot be used further. Secondary or second thing is 0 which was not available for the first blank is now available. That is, you can use 0 for the middle blank or for the second blank, which means you are again left with how many options? 4 options. Now 2 numbers have already been used, one at the first place, second at the second place, which means you're left with how many numbers? You're left with 3 numbers. So how many numbers or how many digits, how many numbers of 3 digits can be formed? That is 4 into 4 into 3. So that is like 48 numbers. That is like 48 numbers. Okay. Now let's take up a question which will include condition, and let's try to understand how can we solve that one. So let's remove this. This is not required any further. Find the total number of 3-digit numbers that can be formed using the above given 5 digits such that unit digit is even and repetition of digits is not allowed. So find the total number of 3-digit numbers that can be formed using the above given 5 digits such that unit digit is even and repetition of digits is not allowed. Another way to put up this question is how many 3-digit even numbers can be formed such that digits are not repeated using the above given 5 digits. Now in this case we have a condition. So let's see how would we go about this question. Now the last digit is even, or if the number is even, which means at this units place I can have 0, 2 or 4. I can either have 0, 2 or 4, which will give me 3 possibilities. So I'm going to put 3 here. Now the repetition is not allowed, so a number used at the last blank cannot be used again. So let's do one thing, rather than going in the sequential order, that is step 1, step 2, step 3, step 4, let's just go from right to left. So I have 3 possibilities for unit digit, that is 0, 2 or 4. One of the numbers used at the units digit cannot be used again, which means now we are left with 4 options. For example, let's suppose I use 2 here. So I'm left with 4 options. Now I'll come to the hundreds place. Now I have already used 2 numbers, which means I'll be left with 3 digits. Now here comes a problem. The problem is, let's suppose you use 2 at the last spot and you use 9 at the middle spot. Now 0 cannot come at the first place because then it will not be a 3-digit number. Now you haven't used 0 at the last place, or you haven't used 0 at the second place, and you can't use 0 at the third place, which means 0 has not been taken into consideration. Now 0 cannot be used, which means I'll have only 2 possibilities. Or if you go the other way around, that is, if I'm using 0 at one of the 2 positions, that is at the second position or at the third position. Let's suppose I use 0 at the third position and then I use 7 at the second position. Then how many possibilities do I have? Now in this case I have 3 possibilities. 2, 4 and 9, all 3 of them will satisfy. 2, 4 or 9, all 3 of them will satisfy. So 0 will create a problem for me. So whenever you have a condition and 0 is a part of that, then always try to make separate cases for 0. Okay. So let's take up 2 cases. So case number 1, when 0 is at the last position, that is only one possibility. Now once 0 is used, you can't use 0 again because repetition is not allowed. So I don't have to worry about using 0 again, which leaves me with only 4 digits for second position and 3 digits for the first position. That's a total of 12 cases. Second possibility, if 2 and 4 are at the last position, which means I have 2 possibilities. Now in this case, I won't go from right to left because I'll end up committing a mistake. So I'll start from left again. And since 0 can't be used here, one of the numbers has already been used at the last position, which means I have only 3 digits to spare. 2 digits have been used, which means 3 more digits are left, which means we will have 3 into 3, which is 9, and 9 into 2, which is 18 more possibilities. So we will have a total of 30 possibilities. In this case. Okay. So if in case the question was repetition is allowed, then I guess you guys can solve it, then it's not a big deal. Because when repetition is allowed, then the question becomes fairly easy. For example, if we talk about the first part, if 0 is there at the first position, last position, that is at the units position, you will still have 1 possibility. Now repetition is allowed, that means you can have any of the 5 numbers at second position and any of the 4 numbers at first position, because 0 cannot come, which means 20 cases. And the same thing you can do for the second case also. So you will have 2, you will have 5, and you will have 4. So that's a total of 40 cases. Okay. All right then. So let's move on to the questions now. Pause the video, try the question for yourself. Then you can play back the video in order to understand how to solve a particular question. Okay. So question number 1. How many 4-element subsets can be formed? Okay. Now let's first talk about the term subset. Subset is basically a part of set. Everyone knows that. It's a part of set which contains elements less than the parent set or equal to parent set. Now, two things which you need to remember as far as subset is concerned is that first thing is repetition of digits is not allowed. That is, you will never say that I have a subset having elements, let's say 1, 1, 2. No, this is incorrect. You can't repeat elements inside a subset. Okay, that's not allowed, that's not possible. Second thing is, there is no such thing as arrangement of digits. Like you will not say, okay, I have a subset or I have a set little. I have a set which has elements like 1, 2. I have another set which has elements like 2, 1. No, this is incorrect. They both are the same sets. S1 is exactly the same as S2. That is, there is no such thing as arrangement of elements. Now, it's not necessary inside a set that you have to arrange the elements in ascending or descending order. You can arrange them as per your own convenience. It won't make much of a difference. So how many 4-element subset of the set are there which contain neither 2 nor 4? So you don't want 2, you don't want 4. That means 2 elements are out. So 2 goes out, 4 goes out. That means how many elements are we left with? 1, 2, 3, 4, 5. You want a 4-element subset. Arrangement is not allowed. Repetition is not allowed. That's like choosing 4 things out of 5 things. That's like choosing 4 things out of 5 things. That is simply selection. So answer to the first one will simply be equal to 5C4, and that is equal to 5 possibilities. That is equal to 5 possibilities. Now what about the second one? Let's see the second one also. How many 4-element subset of the set 0, 1, 2, 3, 4, 5, 6 are there which contains 2 but not 4? Now this line is very important. You need to form a 4-element subset which contains 2. That means one of the elements is 2. So if you have a set, it will be something like this: 2 and then followed by 3 dashes. 2 followed by 3 dashes. 2 is part of the subset. So you are supposed to fill in only 3 positions and ensuring that 4 is not part of it. So 4 goes out, 2 is already here, which means you're left with 1, 2, 3, 4 and 5 positions. Oh sorry, my bad, 5 options. And you need to fill in how many places? 3 places. This is as good as 5C3. So we will have a total of 10 sets or 10 subsets possible. Alright, let's move on to question number 2. Pause the video and try this question, please. Okay, another question with a condition. I hope you guys are able to solve this question. It's a pretty straightforward one. How many different 3-digit numbers can be formed so that the unit digit is always prime? First is repetition is allowed, second is repetition is not allowed. Okay, so let's start with the first case where repetition is allowed. So we need to form 3-digit numbers: 1, 2, 3 dashes. Now we'll be solving dashes individually, which means every dash has a total of or a maximum of 10 possibilities. Every dash will have a maximum of 10 possibilities. So we want the unit digit to be always prime, which means we can have 2, 3, 5 and 7 as my 4 possibilities, because I would want my unit digit to be always prime. Now it says that repetition is allowed, so I'm gonna have 4 possibilities in the end. Now middle position can have any of the 10 numbers 0 to 9, so that gives me 10 options. And the first position cannot have 0, but it can have any of the remaining 9 numbers. We will have a total of 360 possibilities. Now see, when the repetition is allowed, I don't have to worry about the order in which I'm solving the question. I actually went from right to left. Okay, I actually went from right to left. But you do make a habit of always going from left to right unless and until you're like good with this problem type. Okay, all right, let's try the second one. Second one says that the repetition is not allowed. You will again have 4 possibilities for the last position. Now repetition is not allowed, that means one of the numbers that will be used at the last position is not allowed to used again, and 0 cannot come at the first position. One of the numbers used at the last is again not allowed, which gives you how many options? Which gives you like 8 options. Now 2 numbers have been used, one at last position, one at first position. That means you have a total of 8 possibilities for the middle position. So that is 8 into 8, 64 into 4, 60 into 4 is 240, and 16, which is 256. So your answer to this question simply becomes 256. That's it. Okay, try this question, please. Pause the video and try this question. All right, let's see how we can solve this one. So how many 3-digit numbers can be formed using different digits from the list 0, 1, 2, 3, 4, 5, 6, 7 such that product of the digits is even? Now I like this question very much for the fact that usually students do sometimes overread or underread this question. See, the question is you need to use different digits. The question is not that you need to form different numbers. For example, let me make you understand what it is. Let's say I have 3 digits 2, 3 and 4, and the question is find out how many 2-digit numbers can we form, or how many different 2-digit numbers can we form using the digit 2, 3 and 4. How many different 2-digit numbers can be formed using 2, 3 and 4? Different 2-digit numbers. So you will say, okay, I have 2, 2 as one possibility, then I have 2, 3, I have 2, 4, I have 3, 2, I have 3, 3, I have 3, 4, I have 4, 2, I have 4, 3, and I have 4, 4. These are all different numbers. These are all what? These are all different numbers. This is not the question. The question is you need to use different digits. Question is you need to use the different digits. For example, now if I say that how many 2-digit numbers can be formed using the digits 2, 3 and 4 such that digits are different. How many two-digit numbers can be formed using 2, 3 and 4 such that digits are different? Which means this is out, this is out, and this is also out. So how many cases are you going to have? You're going to have like 6 cases. That is, the repetition of the digit is not allowed. This is another way of putting up a question where the repetition of digits is not allowed. Now what's the question? We want the product of the digit to be even. Now interesting case, this is a concept. This is a question which includes 2 concepts. One is from the number system, that is the product of the digits to be even. Another is PNC. Okay. Now, if you want the product of the digits to be even, you want at least one digit to be even. You want at least one digit to be even. You can have exactly one digit which is even. You can have exactly two digits which are even. You can have exactly three digits which are even. All of them, all of them will always give you product as even. Now, if you do it this way, it is solvable. Definitely, it is solvable. It's just that it's going to take a lot of amount of time. So we have an alternate way of solving this question. That is, if you want the product to be even, can I say that will be equal to total number of cases minus the cases when product of the digits is odd. Minus the cases when the product is odd. Because if you have digits, there are only two possible cases as far as product is concerned. One is you can have product as odd. Another is when you have product as even. These are the only two possibilities. I can't have anything else. Now the interesting thing about when the product is odd is that all the digits need to be odd. All the digits have to be odd. Which means I can use 1, 3, 5 and 7. These are the only four possibilities that I can use. Now I want different digits. So let's calculate when the product is odd. So I'm going to have 3 dashes. Now the first place I can have any of the four numbers, that is 1, 3, 5, 7. Second place I can have any of the 3 and then any of the 2 numbers. That will give me a total of 24 cases when the product is odd. Now I need to calculate the total possible cases. So again I'm going to draw 3 dashes. 2, 3. Again 0 cannot come at the first position. Now there is no condition. I'm simply solving, or I'm simply calculating the total number of 3-digit numbers that can be formed using different digits. 0 cannot come at the first place. That means I can have any of the 7 numbers coming at the first place, 1 to 7. Now 0 can come at the second place, and one of the numbers used at the first place cannot come, which means again 7 position. And for the last one, again I'm going to have 6 positions. So this basically becomes 49 into 6. So 49 into 6 will give you 294. So cases when the digits, when the product will be even, will simply be 294 minus 24, and that is equal to 270. Okay, so these will be the total number of cases when the product will be what? Product will be even. So this one was tad but interesting. Alright, let's move on to the next question. Pause the video and try this question, please. Okay. Another question which consists of concept from number system as well as PNC. This is bit different than what we have been doing till now. Find the sum of all 4-digit numbers that can be formed with the digits 3, 4, 5 and 6. First thing first, we need to calculate the total number of 4-digit numbers that can be formed. So 4 dashes. Now repetition will automatically come because we just discussed that 4444 is also a valid 4-digit number. So we will have 4, 4, 4 and 4. So that is a total of 256 cases. So we're going to have a total of 256 cases. Now there is no condition given to us, right? If there is no condition given to us, which means every number at every position will come for equal number of times, or every digit at every position will come for equal number of times. So you can say that 3 will come at the first position for 64 number of times because we have 256 cases, which means 256 cases basically means you're going to have like 256,000 digits. You're going to have 256 digits. You're going to have 256 tens digits, and you're going to have 256 unit digits. So for 64 times, you're going to have 3 at the first place. 64 times, you're going to have 4 at the first place. 64 times, you will have 5 at the first place. 64 times, you will have 6 at the first place. Now, you want to add up these numbers. So let's go back to number system a bit. If I talk about a 2-digit number, let's say the number is AB. I can mathematically express this as 10A plus B. A 3-digit number ABC can be mathematically expressed as 100A plus 10B plus C. So if I have a 4-digit number, let's say I have A, B, C, D, it can be represented as 1000A plus 100B plus 10C plus D. Okay, so that can be written as 1000A plus 100B plus 10C plus D. So what will happen at every position is that at every position we'll have 364 times, 464 times, 564 times, and 664 times. At every position, I will have 364 times, 464 times, 564 times, and 664 times. Which means if I only talk about the sum of the digits of a respective position, if I only talk about sum of the digits at a respective position, then I can say that the sum will be equal to 64 times 3 plus 4 plus 5 plus 6. Because what will be the sum? The sum will be 3 into 64 plus 4 into 64 plus 5 into 64 plus 6 into 64. I'm talking about individual places. I'm not, as of now, I have not even started calculating the sum of the 4-digit numbers. I'm only calculating the sum of the digits at every position. So this will basically become 64 times 9 plus 9, that is 18. So at every position, we can say that the sum of the digits will be equal to 1152. At every position, sum of the digits will be equal to 1152. Now, if we convert this into a 4-digit number, so this will basically be 1152 for the last position, that is for the units position, plus tens position will be 10 into 1152, 100 will be 100 into 1152, and 1000 will be 1000 into 1152. I'll just write it properly. So 1152 into 1000, 1152 into 100, 1152 into 10, and 1152. There was an off here. Now this will be the sum. This 1152 represents sum of the digits at every position. This represents sum of all the digits at the respective position. Now you can take 1152 common. This is 1000 plus 100, that's 1100 and 10, 1110, and this is 1111. So this is your answer, that is 1152 into 1111. This is your answer. Now if you want, you can solve this, but anyways, the concept is of the prime concern here. So this is how you are supposed to solve a question like this. Something that I am expecting in the upcoming GRE GMAT exam. This is like one of the questions which haven't had appeared till yet, but something which can come in the exam. Okay. All right. Let's move on to the next question. Let's try question number 5. All right. Let's see how we can solve this question number 5. Number of 4-digit telephone numbers having at least one of their digits repeated. Okay, at least one of their digits repeated. Number of 4-digit telephone numbers having at least one of their digits repeated. Now, at least one of their digits repeated can be put up in this way also. That is, you calculate the total numbers without any condition and subtract the cases when all digits are different. Subtract the cases when all the digits are different. So number of 4-digit numbers, you can't have 0 at the first place, right? So that's 9. Then you can have any of the 10 numbers, 10, 10 and 10. So this will basically give you like 9,000 possibilities. Now all digits different, 1, 2, 3, 4. You can't have 0 at the first place. That gives you how many options? 9 options. One of the numbers used at the first place cannot be used again, but 0 can be used again. That again gives you like 9 possibilities. Two numbers used at the first two places, which means you'll be left with 8 possibilities. Then you will have 7 possibilities, which gives you a total of 4,536 possibilities. So number of 4-digit telephone numbers having at least one of their digits repeated should be equal to 9,000 minus 4,536, and that is, you will have a total of 4,464 cases. If you do it by forming individual cases, that will take a lot of amount of time. That is, for example, you can have cases such as, you can have repetition of digits at the first place and the second place. You can have repetition at first and third, repetition at first and fourth. Then you can have repetition as first, second, third, first, second, fourth, second, third, fourth. There is no point of calculating all the cases. You want at least one of the digits being repeated, so that is total number of cases minus when all digits are being different. That's it. Okay. Let's move on to the last question for this video. Pause the video and draw this question, please. So question number 6 is, how many 4-digit numbers each divisible by 4 can be formed using digits 5, 6, 7, 8, 9? Repetition of digits being allowed in any number. Okay. So we need a 4-digit number. We want the number to be divisible by 4. So again, a concept of number system as well as PNC. If you want the number to be divisible by 4, then that means the last two digits should be divisible by 4. So what all possibilities can we have? We can have 5, 6. We can't have 5, 7, 5, 8 or 5, 9. Another is we can have 6, 8 going in the chronological order. With 7 we can have 76. With 8 we can't have 85. 86 is also not a possibility. Can we have 88? Repetition? Okay, repetition is being allowed, so that means we can have 88. Then with 9 we can have 96. If the number is to be divisible by 4, then for the last two positions, these are the only 5 possibilities. Now corresponding to each possibility, we just need to figure out that at the first two positions how many numbers can we have. So for the first position you can have either of the 5 numbers because repetition is allowed, and for the second you can again have either of the 5 numbers. So that is like 25 possibilities. So we will have a total of 125 cases. We will have a total of 125 cases. So that is all as far as digit problems of PNC is concerned. This is what the concept that you need to know. Now you are good as far as concepts are concerned. You just have to practice the questions. Okay, so this is like pretty straightforward as far as PNC is concerned. So I think more or less we are done with the PNC. We are done with the word problem. We are done with the basics. We are done with the digit problems also. So thank you so much guys for watching the video. Keep watching, keep learning. Please do share and subscribe the channel. If you have any concerns, if you have any question, you can always connect with us. And if you're looking for personalized classes for SAT, GMAT or GRE, you can always WhatsApp us or you can always mail us. Thank you so much everyone.